My name is Alyssa and I'm a third year forensic investigation student at Staffordshire University. This presentation will cover my dissertation looking into the impact distance and container type have on chemical attacks. The purpose of this research project was to address the issue of rising chemical attacks in the UK. Between 2014 and 2018, London experienced a 270% increase in chemical attacks, which likely lessened during COVID-19, but there was no evidence the crime would subside once the pandemic eased. Research concerning the analysis of garment damage caused in chemical attacks would provide valuable information for forensic investigations, but available information in this area is very limited. This research aimed to investigate whether distance had an effect on chemical damage patterns created during chemical attacks and whether container type would have an impact too. The conclusions made from this study would be applied to assist police investigations into corrosive attacks. The following slides will explain the experimental process and the results of this work. The chemical substitution used in the experimental work was created using 81 grams of corn flour, 240 millilitres of deionized water, and 60 millilitres of pink food colouring. The corn flour and deionized water were combined to make a liquid which possessed a similar viscosity to sulfuric acid that could safely be thrown towards an intended target. The pink food colouring was added to the mixture to ensure the substitute chemical could be clearly seen during the chemical attack recreations. Once the chemical substitute was created, 100 millilitres was separated into the fruit shoot, Lucozade sport and water bottle containers ready for use in the attack recreations. A scenario of a chemical attack was recreated by the experimenter throwing the chemical substitute from each container in one swift arm movement towards a garment worn by a mannequin. The damage to the garment was created from distances of 0.5 metres, 1 metre, 1.5 metres and 1.8 metres. The damage caused by the chemical substitute expelled from each container type and distance was observed on clean garments for each test. The damage patterns created during the recreations were photographed and image J was used to measure the surface areas. Through statistical testing, this project found significant differences between the surface area measurements recorded from all four distances. The largest surface area measurements were recorded at 1 metre. Significant differences were also found between the surface area measurements recorded from all three containers, except when the chemical substitute was thrown from 1.5 metres. So, at a distance of 1.5 metres, a difference was not found in the surface areas created by the different containers. Out of the three containers, the water bottle was recorded to create the largest surface area measurements. The information resulted from this project could be used to assist police investigations by determining the distance or container type used in a chemical attack. This research has shown that analysis of garment damage can help to establish the possible distance or container used based on the surface area of the damage to the garment. This information could also help police to identify other areas of evidence to retrieve. For example, the knowledge of what container type should be searched for during an investigation, and determining the distance could assist in obtaining CCTV focused on the point at which it is suggested the perpetrator was situated. This research has also shown that the measurement of damage pattern surface area could provide sufficient information towards an investigation and should be included at fabric level in textile damage analysis. Thank you for listening.